Solving two-step equations. When solving, we want to isolate x while keeping the equation balanced. Problem 1. On the left we have 3 x's and 2 positives, and on the right side we have 10 negatives. In order to solve for x, we want to get x by itself, so we want to get rid of these 2 positives. I could subtract them, but an equivalent way would be to use 2 negatives. A positive and a negative are going to cancel out, and that's equivalent to subtracting 2. Leaving me with just the 3 x's. The scales are no longer balanced, so I'm going to add 2 negatives to the other side. Negative 10 and 2 more negatives. I now have 12 negatives on the right side. Now, since I have multiple x's, x being multiplied, I want to sort these into sections. Let's go ahead and create sections. I'm going to divide these into 3 groups. Since I divided the left side into 3 groups, let's do that to the right. So we're going to divide these into 3 equal sections. So, mathematically, on the left side, we divided this into 3 groups to get a single x in one section. And on the right side, we took these 12 negatives and we divided them into 3 groups. And we see that in one section, we have negative 4. So know that one of these x's weighs the same as negative 4, or x equals negative 4. Problem 2. Here we have 4 x's and 3 negatives, and on the other side we have negative 11. To cancel out 3 negatives, I need the opposite. I need to add in 3 positives. 1, 2, 3. So that's equivalent to adding plus 3 to the left side, leaving me with the 4 x's. To keep things balanced, since I added 3 to the left, I need to also add 3 to the right side. So 1, 2, 3. Adding 3 to the left side. 11 negatives and 3 positives. Notice that they cancel out, giving us 8 negatives left over. Now, to solve for x, since we have multiple x's, x being multiplied by 4, I'm going to group these into 4 equal sections. So let's go ahead and sort them out into 4 equal groups. But since I divided these into 4, let's go ahead and divide these into 4 groups. And that looks like it's already kind of divided. So here, we're dividing the left side into 4 groups, giving us 1 x in the section. And here we have 8 negatives, divided that into 4 groups. We have in one section, negative 2. So we have x equal to negative 2. Problem 3. Notice that we don't have a complete x here. We have a third of an x, and we have negative 6 on the other side. Our first step in solving this problem is to figure out what each of these pieces represent. What's 1/3 of an x going to be? So let's go ahead and start off by sorting these into sections. I'm going to divide these into 2 groups. So we're going to divide it into 2 groups. And over here on the right, we're going to sort the negative 6 into 2 groups. So we have divided by 2. So after dividing into 2 groups, I see that we have 1/3 of an x, a third of an x, equal to negative 3. This fraction is equal to 3 red balloons. So now that we know what one of these pieces is, if I want to add in a third piece, I know that each piece weighs negative 3. So now I can combine all 3 parts. I want to multiply this by 3 parts to make 1 whole x. So let's go ahead and put these together to get 1 whole x. Times it by 3 to get a complete x. I know that takes 1, 2 times 3 in order to get the same amount. So after multiplying by 3, I have my complete x. And over here, after multiplying it by 3, times it by 3, we know that 1 complete x weighs the same as negative 9. So x equals negative 9. One shortcut people like to think about is, in order to solve for x, notice that we had to divide by 2 and then multiply by 3. Times 2 and divided by 2 cancel each other out. And multiply by 3 and divide by 3 cancels out, giving us just x. Problem 4. 5x divided by 4 equals negative 20. On the left side, we have 5 pieces, each of them representing a fourth of an x, and on the other side we have negative 20. Our first step is to figure out what does each of these fractions represent. What does a fourth of an x weigh? So let's go ahead and make some sections. And we're going to divide these into 5 equal sections, so we can figure out what each of these parts weigh. So I'm going to divide by 5 to get x over 4, a fourth of an x. Each of these are a quarter tile. And since I divided the left side, I need to divide the right side into 5 equal parts. And I can see after dividing it by 5, I know that each section, each quarter is worth 4 red balloons, negative 4. So I know that a quarter of an x is the same as negative 4. But I don't want to figure out what a quarter of an x is. I want an entire x. So I need to multiply this by 4 parts. I want 4 parts to make a complete x. So let's go ahead and combine these to get 1 whole x times 2 times 3 times 4. I have 1 complete x. So since it takes 4 parts to make a whole, let's combine 4 of these parts together. And I see that after multiplying both sides by 4, 1 complete x is equal to negative 16. One shortcut people like to think about: first we divide it into 5 sections, then we multiply it by 4 parts. Dividing by 5 helps us figure out what each of these fractions represent, and then we multiply it by 4 because 4 parts makes a whole tile. Problem 5. Here we have half an x and 5 negatives, and on the other side we have negative 2. In order to solve for x, we first want to get x by itself, so we need to cancel out these 5 negatives. To that, I'm going to add 5 positives, and each of these positives are going to cancel out. So that's the same as adding plus 5 to the left side, leaving us with our half of x. Right now our scales aren't balanced, so let's go ahead and add 5 to the other side. So after adding plus 5, we notice that the negative 2 and the 5 canceled out, leaving us with 3 tiles left over. So we know that half of x equals 3. We're not quite done yet because we want a whole x. So if we know half of x equals 3, if I double the amount of x, if I double, multiply by 2 times 2, I get 1 whole x. And if I double the left side, I need to double the amount of tiles on the right side. So after doubling, after timesing it by 2, I know that 1 whole x is equal to 6 tiles. X equals 6. When solving multi-step equations, we can use opposite operations in order to cancel out. We know that addition and subtraction are opposites, so they undo each other. And we know that multiplication and division are opposites, so they undo each other.